The scalpel is the surgeon's trademark tool. Its short blade is razor sharp and designed to slice swiftly and cleanly. This little knife may seem like a simple instrument, but its incredible precision, along with the surgeon's steady hands, is key to a safe and accurate medical procedure. Scalpel handles are made from rods of stainless steel. The blades are made of either carbon steel or stainless steel. They're sterile and designed for one-time use only. The blade steel is extremely thin, less than 2/100ths of an inch. It arrives at the scalpel factory in coiled strips. The first machine feeds the strips into a press. A die inside punches out unfinished blades called blanks. Blades will vary in size and contour, but they all have the same center slot for attaching the handle. When you flex a blank, it bends entirely out of shape. That's because the steel still needs to be tempered. The blanks pass through a furnace for about 30 seconds. The heat alters the molecular structure of the metal, hardening it. Now the blank has the flexibility a scalpel blade requires. Next, the blanks move through a punching tool that pops them from the strip and stacks them on a peg. A worker threads a metal ring through the slots to keep them together, then sends the whole set of blanks for surface polishing. This process will restore the metal's original sheen, which was dulled by the heat treatment. Next, workers visually inspect every blank, discarding any defective ones. They transfer the blanks from the ring to a metal rod, using a gauge to measure out the right number. From here, the rods are mounted onto grinding machines. Each one picks up a blank with a magnet, then places it in a holder. The holder runs the blank against a wheel coated with diamond particles. This powerful abrasive shapes and sharpens a cutting angle, transforming the blank into a blade. As the blades come off the grinder, they cling together, because the magnet that fed them into the machine magnetized them. To cancel this effect, a demagnetizing machine passes an electromagnet behind the stacks of blades. After a thorough washing in an ultrasonic cleaning tank, the blades move on to final inspection. Wearing protective rubber gear, workers carefully scrutinize the cutting edges, discarding any blade that's less than perfect. Each and every blade passes through 2 different inspectors. In the packaging department, a machine covers each blade with a brown paper strip that contains an anti-corrosion chemical. This provides extra protection against rust. A second machine slips each blade into a foil packet, then cuts the packets apart. Each packet bears the blade model number and tracking code. As the blades come off the packing machine, an inspector does one last quality check. Then he counts the blades and boxes them. Of course, it's critical that surgical blades be sterile. So the boxes go into a cobalt radiation chamber for about 6 hours. This obliterates any lingering contaminants. When the boxes exit the chamber, they're hospital ready. In the operating room, it's simply a matter of sliding the blade onto the protruding part of the handle, called the bayonet. Surgeons make the most of their dexterity by choosing a handle that best fits their hands and best suits the procedure their hands will be performing.
A hypodermic needle is the proper term for a syringe and needle. It's used to draw blood or inject medication. This indispensable tool was invented back in 1853, but it wasn't until 1954 that mass-produced disposable syringes came on the market, developed for the vast immunization campaign against polio. A syringe may make you cringe, but the treatment it delivers could be a lifesaver. To make a hypodermic needle, they start with a flat strip of stainless steel. A milling machine rolls it into a tube shape. A laser welds the seams together. But what makes the steel stiff enough to use is something called cold work, in which they press the tubing through a die several times. This also slims the tube dramatically, so now you have a thinner, tougher tube. It takes about a couple of days to turn the stainless steel strip into a tube with needle potential. But it will have to be sharp to perform, and the next steps will focus on getting the steel tube to a point where it's more than just a blunt object. An electrically powered blade scores the walls of the tubes as rubber pads bear down and roll. This rolling causes the tubes to finally break at the score line. The tubes are being cut down to size, about 5 centimeters long. The tubes fall into a bin, a tangled mess. The bin, driven by air pressure, agitates, and this shaking motion straightens them out. An operator bundles them together with a plastic band, but removes a few to check the specs. This micrometer uses laser light to measure the outside diameter. The tube is supposed to be 2 millimeters, and it's right on. Next, a mechanically driven drum rolls super adhesive tape onto the tubes. The tape will hold the tubes in place as more work is done on them. They razor cut 12 centimeter strips of the tape tubes so that there are about 100 tubes per strip. Then they spray aluminum oxide on the ends of the tubes. This roughs them up so that the surface will be easier to work with. Now they place the strips of tubes into the grinding fixture, and then they snap it shut. Coolant flushes over the tube tips as the fixture moves across a grinding wheel. The wheel grinds through the tops of the tubes, shaping them into a rough point. This is only the first grind, so it's not yet needle sharp. Now the fixture rolls and rotates the tubes. Then it's back to the grind. The angle of the wheel is changed so that it sands the sides of the tubes. These two secondary grinds sharpen the tubes into a finer point. This is how they looked before grinding, and this is after, with their sharp needle tips. Now it's time for the big inspection. She pushes the ends of the needles with the back of her tweezers to make sure they're even, and then pulls out a needle for sampling. She measures the length of the grind. It should be a few millimeters long. Next, she sizes up the needle's outside diameter with a micrometer. Holding the needle between posts, it measures the space between them. Then she checks the inside diameter by inserting a plug gauge into the tube. Now she inspects a whole bundle of needles for irregularities or burrs. Using tweezers, she removes one for a close-up look under the microscope. Once they pass inspection, it's on to the big wheel or the automated assembly machine. Brass and nickel-plated fittings called hubs drop onto pins on the wheel. Then needles fall into the hubs. Metal fingers align them so they fit together precisely. The hub is the piece that will connect the needle to the syringe. Automated crimpers press the needle into the hub. Sheer friction bonds them. Now 2 metal pads on the same wheel position the needle. A plastic sleeve drops down, encasing the pointed tip. Finally, a robotic arm lifts the needle off the wheel and drops it into a bin. The needles are now ready for you, but are you ready for them?